What we're going to do is we're going to look at graphing quadratics and cubics. So far, we've done graphs for square roots and cube roots. And we're going to move into inverses. And these are the inverses of square roots and cube roots, as we've kind of already discussed a little bit. So there's a lot of detail that I'm not going to explain everything of. What I want to do is go over just the quick way of giving a nice sketch for graphing a quadratic or graphing a cubic. The main thing that we need to get out of each one is the vertex, and this is called an inflection point. It's kind of like our center point of the graph for the cubic. It's our HK value. And then after we find our HK value, what we're going to do is we're going to use our A value, kind of similar to a slope, and that's going to help us graph these. So our quadratic is our parent equation. It's going to look like this, where if our A value is positive, it's going up. And if our A value is negative, then our quadratic is going down. Now for a cubic, what we're going to do is our parent equation is going to go up and down, and that would be when A is positive. And then when the A is negative, what it's going to do is it's going to go down. So looking at this, the first thing that we're going to do is, in this case, find the vertex. So that would be 3, -1. And then what we're going to do is we're going to graph it based off of our A value. And our A value is 1. So what that means, and it's a positive one. So our A value is positive, so we know it's going to go up. So we have our 3 and -1, and we're going to go up 1 and then to the right and left. And what we're going to do is make kind of like a U. Our domain is going to be -infinity to infinity, and our range is starting at -1, and it's going to go to infinity. So for the next one, what we're going to do is we're going to find our vertex, and that's -2 and 2. Remember, it's always the opposite inside, and it's the number outside. And so when we graph this, what we're going to do is we're going to look at our A value. Our A value in this case is a -1. So that means that instead of the U going up, what we have is a U going down. So we're going to graph our vertex, -2, 2, and then what we're going to do is we're going to go down 1 and then to the right and to the left. And that right there gives us our graph. Our domain is going to be the same, and what we have is -infinity to infinity, and then our range is going to be -infinity to 2, +2. Now, if you look at letter C, what we have is a cubic. So instead of a vertex, we call it like an inflection point. It's the center point, 1, -3. And what we're going to do is we're going to take that, and it's going to be similar to what we did on the last two. But if you remember with the parent equations, they're going in opposite directions. So that means that when we're graphing it, we're still going to look at our A value. And so we have 1, -3, and our A value is 2. So that means we're going to go up 2 to the right one, and then we're going to go down 2, and then to the left one. And so what we're going to do is we're going to kind of make it as curvy as we can. Not the best graph. And that right there is our cubic. Now our cubic, just like our cube root, is going to be the same, -infinity to infinity. And then our range is also going to be -infinity to infinity. For letter D, we have another cubic. We can tell that it's a cubic because it's degree 3. We're going to find our inflection point. That's our center point, -1 and 2. And so when we graph this, what we're going to do is we're going to plot it, and then we're going to look at our A value. And we notice that our A value in this case is 1. So that means that we're going to plot the -1, 2. We're going to go up 1 to the right one. We're going to go down 1 to the left one. And then what we're going to do is we're going to make it curved. Once again, our domain is the same, -infinity to infinity. And our range is also the same, -infinity to infinity. Now for letter E, this one's a little tricky because we don't see an opposite inside. We don't even see an inside. So that tells us that it's 0. So we have 0, 5. And so when I graph this, what I'm going to do is I'm going to make my x-axis go a little bit lower so I can fit it all in. Actually, that's should probably make it a little bit lower than that because I'm going to have to go up 3. And so what I'm going to do is I'm going to plot the 0, 5. 1, 2, 3, 4, 5. And then since my a value is -3, I'm going to go down 3 and then to the right one and up 3 to the left one. So my graph is going to look like this. Once again, domain and range is the same, -infinity to infinity. And the range is -infinity to infinity. Now for our last one, we have a quadratic because it's degree 2, and our vertex is 4, 0 because we don't have anything afterwards. So when we graph this, what we're going to do is we're going to plot the 4, 0. And since it's a half, that means we go up a half and over 1 for each one. And then what we do is we draw our graph. Our domain is going to be -infinity to infinity. And our range, notice that our lowest value is 0, and then it goes to infinity.